Jag heter Andreas Södermark och är VD för Euvic Sverige. Det är vi som har fått äran att bjuda in er här idag. För er som inte känner till Euvic så har vi 15 års erfarenhet av digitalisering. Det är allt från att hjälpa Samsung Norden med sitt nya internet till att hjälpa Pokébank som är en av Finlands största utmanare inom finansförsäkring till att totalt revolutionera sin app och sitt kundbemötande. Där man går från 2,5 på App Store till 4,5 till att hjälpa Arriva med sin omställning där man digitaliserar hur man kör bussar och tåg. Vi kan digitalisering och har gjort det länge. Även om vi inte är kända i Sverige så är vi väldigt kända i Europa. Vi har utmärkelser från Forbes och Ernst & Young för vår tillväxt. Och Gartner har nämnt oss i flertalet rapporter för just den digitala omställningen och exempelvis Ideation as a Service, där vi hjälper bolag att se vad för möjlighet egentligen i den digitala omställningen. Vi är 2500 anställda i gruppen, men vi tror stenhårt på partnerskap. Vi tror inte idag att en leverantör kan göra allt. Vi tror att vi behöver bygga ekosystem tillsammans. Och därför har vi bjudit in idag både Neiron och Peltarion som är helt fokuserade på AI för att ge er här idag den bästa insikten i de use cases som finns, hur man kommer igång och vad man ska tänka på. Så att vi är faktiskt 3 som ställer upp här idag och ger er våra insikter. Och den agenda vi har, som jag ska släppa över snart, är att Peltarion kommer börja här prata om AI och sin plattform och flera use cases. Sen kommer Neiron, en partner, gå igenom deras use cases innan vi gemensamt försöker hjälpa er med how to get started. Och presentationen kommer vara på engelska, eller hur Lina? Ja. Och hoppas det är okej med er. So far so good, är vi med? Bra, Lina, vill du ta över?
Good, thank you. Yes. Good morning everyone that is joining us here at Euvic's offices in Stockholm. And I know that we might have participants online, so also welcome to them, or the people looking at this recording later on. So I'm Diana Lindberg, and I work as an AI solutions engineer at Peltarion. And my job is to meet and engage with companies and organizations that want to embark on this AI business, AI journey. I help them to make processes and products, services more efficient and more effective by using AI. So before we go into the AI world and the NLP, I want to start with my company's vision. AI is a disruptive technology that is going to change the way how we interact with each other, how we work, and how we live. And it is certainly that a lot of tech players and big companies know how to make use of that technology. However, organizations and companies like us, where we work today, haven't been making that advantage of the technology quite yet, because it has been difficulties starting with the journey, or they have difficulties to put it in production, to moving from a research POC stage to a deployment. We at Peltarion want to change that. We want to democratize AI so everyone can have access to the technology in an affordable and easy way. And this is what we have been working for the past 4 years. We are creating an operational AI platform that is helping organizations to come and create AI systems much faster. We know that creating technology, that creating AI systems is a very complex task. It requires a lot of data, it requires a lot of tweak, it requires a lot of knowledge of how to do it. And what we want to do with the platform is to extract out all the mundane tasks that are really not related with the problem that your domain companies are doing, so you can focus on solving those problems. The company started actually in 2004 when our 2 founders met in Cotijoa when they were studying, and they found Peltarion as a consulting firm. They have a product that back in the days were very heavy in using neural networks or deep learning. Long before deep learning was something that the world realized it has a great potential. In this graph, you can see the red line is actually the Google Trends results for the word deep learning. So you could see that the peak started more or less in 2015, 2014, and then it has been going up and up. Around this time was when our investors approached Peltarion and he said, why not we change the strategy? Also, our founders wanted to replicate all the experience that they have with all these kinds of companies that they've worked in the past, and change from a consulting company to a product company. And that's what we are right now. From 2 people, now we have just crossed the 100 mark in number of people working at the company. So what is our focus? Besides the platform, which is our core product, we are a product company. We have seen in the market that difficulties for companies to start with AI. So we have now a service pillar where we have a team of data science experts. They had used AI, had applied AI to help those companies to get going. We give them the first push, helping to find the right cases, how they start with the platform, and then the idea is that they can continue the journey by themselves. We are not a consulting firm, we are a platform company. With that, we also have our partners like Neiron. They help us in that push with our companies they need, so that help that they need to get going. And then the third pillar that we have is also we are committed to the education and training. Everyone needs to know about AI. And sometimes companies need that help, master classes, or they need some education on AI, what can do, what cannot do as well. So we also offer this kind of services. So that was Peltarion. And then let's go into the AI. So based on the surveys, I don't need to go too deep down into this. So by now, I guess everyone knows that AI is not a new technology. It's a science that started long before, like 50s, around the 50s. And it was created as an academic science to create intelligent machines. That was the goal when it was created. But it turns out that creating intelligent machine was quite a hard task to do. So decades later, machine learning, which is a subset of AI, start aiming to, instead of creating intelligent machines, let's teach the machines to become intelligent. And the way to do so is to using data, lots and lots of samples, showing the systems data that start learning to automatically make predictions. And this started getting some traction back in the 80s, 90s, early 2000s. But what it really caused, this revolution that we are experiencing right now, is deep learning. And deep learning is a subset of machine learning. When you were using some algorithms in machine learning, think about an algorithm as a recipe, how to transform the data to get those predictions. In deep learning, those algorithms become more complex, more deep, and they use more data. Here in this field is where all the breakthroughs in image classification and understanding of objects in an image had the breakthroughs in 2012. And after that, it was a whole generation and development of better algorithms and better objects that could identify things in images at the same time, at the same level that a human, and sometimes better than a human. So this is what it has caused the whole revolution. And it's in this area where Peltarion has the expertise, deep learning. Another key difference between these two, machine learning and deep learning, is that the type of data. In machine learning, you use structured data. And by structure, I mean data that you could put in a table, data that you could put in columns and rows. That's structured data. While deep learning is unstructured. So think images, good example, but also think of text, free text, or audio, or sound of machines. So think about how some cognitive things of the humans, they can see, they can talk, they can read, they can listen. So that could be also a good way to understand the difference between both of them. You need lots of data, and also I guess that when you look at AI, at some typical examples, medical diagnosis is a very, very good example where the potential of deep learning has been showing good results. And in these unfortunate times that we are right now, with the corona disease spreading all over, I thought we could use both of the most common things that we're talking today as an example of how AI could be applied. I'm going to start with the right-hand side example. This is an image of Euvic, a company, as many other companies in China, are creating systems that it can detect if a patient is infected with the coronavirus or not. Euvic has a background in detecting lung cancer, but since it is very important for us to detect the early patients contaminated with the virus, they have taken CT scans of all the people have been found with the coronavirus, train a model to know the difference, what is the disease that they have in the lungs, and then make a prediction. This specific system, it has like a 95.2 or 3% accuracy. And what it helps is that in 20 seconds, they can say, yes, this patient is infected or not. So all the frontline health caregivers can take the time to see how they isolate the patient, how do the treatment, and then how to cope with the amount of people they need the diagnosis. This is using images, CT scans. On the left-hand side, then I have another example, and this is a company called Blue Dot. It is a Canadian artificial intelligence company that is in the business of predicting when the next infectious disease outbreaks are coming. That was actually their business. And they sent the first warning of what it was going to happen already at the end of last year. For the Center of Disease Control and the World Health Organization, it took a week or more than a week to send the warning. How did they do it? Well, they used natural language processing, and they were scanning. This is not because of the coronavirus, it's because it's their business on infectious disease. They scanned more than 100,000 data sources on news, blogs, forums, etc., in 65 different languages worldwide every 15 minutes. And they look for specific patterns that it could give them clues that something is on the way, something is going to happen. When the system has detected some interesting findings, they alert their system, their epidemiologists and their doctors and their expert team to review and verify what they have found, use some verification in a scientific way, and then if it's something that is really happening, then send the warnings. And that's how this warning came way before the other organizations could do it. So since Blue Dot use NLP, let's go into our, and I took the wrong button, to our main topic of today, and it's natural language processing. I just wondering, so is someone familiar with this? Has worked before? Good. So NLP, everyone says NLP, but it's natural language processing. It's actually the field of understanding how humans communicate. We do it through language, and create systems that can replicate that behavior to create a more natural way that we can communicate with machines. That's the aim of NLP. And what has happened is that recently there have been many breakthroughs into this field, and to be more exactly in the last 2 years. And those breakthroughs that have happened, it can be compared to what happened in 2012 with the image classification field. So back in November 2018, Google open sourced a model called BERT that it was trained in the whole English Wikipedia. Also, I just want to make a break here, and then some Andreas, I don't know where you sat now. Andreas mentioned at the beginning, to make some AI systems models, you need lots and lots of data. So Google took the whole English Wikipedia, plus hundreds of book corpuses in English to train this BERT model. it turned out to be more than 3.5 billion English words used to go to the training. And the result is that that model could understand English text in a way that no any other model could do it ever before. And this is the big breakthrough. Could be seen as the inflection point of what NLP is to offer today. After that release, many other companies, Microsoft, Facebook, and Google, have been creating BERT-based models to get some additional understanding in different tasks, elevating the grades of how those models understand the language. So large data sets, better algorithms combined to transfer learning is opening a lot of opportunities to organizations that have text to be AI enabled. Transfer learning, before we continue. You need to have a lot of data, but when you use an already pre-trained model, like BERT or any other models, you don't need to start your training from scratch. You can take what those models have learned from those large data sets and fine-tune it to your specific domain. Let's make an example. If I'm in the finance world and I have very specific terminology in my industry, if I use BERT that is being trained in English Wikipedia, it might not give me the results that I expect because it is not trained in financial data. But what transfer learning does is that I take my data and fine-tune the learnings to understand my domain level vocabulary. And this is also something that it has been very powerful in the ways how NLP can be used in real scenarios. So now, who is familiar with BERT? Which BERT? The Sesame Street BERT or NLP? I was meaning actually the bidirectional encoder representation from Transformers. And I asked this question sometimes because people said, well, which one did you mean? Sesame Street or the model? Context. I didn't give you any context. I cannot trick you with the BERT image there, but you were very smart. You didn't fell for it. But that's an example how our language and the way how we communicate is always related with context. Think when you are, I'm not from Sweden, I'm actually from Latin America. My first language is Spanish. And when my husband comes and says, how do you say this word in Spanish? And I'm like, what do you want to say? Because I always need to know the context in order to give him which is the best word in Spanish for what he wants to say. So context is one important thing, and then the second one is attention, and you're going to see it shortly. So here I have two examples, open a bank account and how is a river bank formed. So we have a word bank, and the way how traditional models use to interpret a word, a sentence, or a paragraph is that they assign a vector of numbers, something that we call embeddings. You don't need to remember this, just they assign certain embeddings to specific words, paragraph, or sentence to represent the meaning of the word. In this case, traditional models, we assign to bank the same embedding or the same vector representation. But after BERT, that is taking into account context, it knows that the first bank, it refers to the financial institution, while the second bank, it refers to the part of the sand by the river. This is one important key of what this whole revolution has happened. The second one is attention, and it's very much, are you putting attention what I'm saying? If I later on ask a question, just think about it in these terms. So here I have a piece of text where it starts the technical accounting was scheduled to do something and they were going to be away. And then it gets done some other pieces of text. And then it says the latest change was made by the ADX department by one of the newest employees who didn't review the protocol, and he or she was not aware that they were away that week. For us, even if it's a long sentence, we just, okay, what are we talking about? The technical accounting. So you know that the day means that team. And this is also something that Bear has brought, that it is able to, in large extent, parallel process bigger pieces of text to understand all the connections of all the words that are in a text, to know what is the real meaning of each of them. Traditional models, once again, the span is quite short. They are more sequential. It could be from left to right or right to left, but they cannot hold that much parallelism as BERT does. And this is what it makes that NLP, we are in the front of something that we could really be used in real cases. Last thing, I promise, before we go into real examples, because that's what I see a lot of want to hear, is that the language is bidirectional. We need to know everything that is coming before and after in order to know what something has as a meaning. Some of the languages, traditional, go only from left to right, or so only from right to left, but with BERT they go both ways. So first example, we have the cat didn't eat the food because it wasn't hungry. And the way how we know, or the systems know, that it relates with cat is the last word, hungry. In the second example, fresh changes the meaning of it to the food instead to the cat. And for us, it might be very natural, we do it, but it wasn't the same thing for systems, which now they're getting there. Good, so let's see, okay, how can I use all these breakthroughs and all these new algorithms in practice? First, like you want to have some text categorization. You have some free text. You want to categorize, for example, customer service requests, if it's going to finance department or is it going to the technical department. So you can use these algorithms. You can also use it as a sentiment analysis, and this one you could see it as a text categorization, but with very specific tags. And this one could be neutral, positive, or negative. You have a product, and you are looking at reviews from your customers. You have a service. If it's a negative review, maybe you want to act much faster than if it's a neutral or positive review. Another one is the name entity recognition, and this one is also systems that focus on a specific objects of the text. Let's say you wanted to follow what is being said of your product, of your service, your company, top management of your organization in social media. So you can establish this name entity recognition to see, okay, any time that someone says or is named in the social media or the news, you have an alert. I might speculate, I don't know because I'm not familiar with the internal way how Blue Dot makes their screenings, but I might guess that name entity recognition could be something that they are looking at when reviewing all this data sources. And then we had something, textual similarity, and this is, it tells you if two pieces of text are similar, but in the sense of semantically. Not, do they have the same words? It's not enough because we know same words could mean different things, but even though they don't have the same words, do they mean the same? And I will show you an example of this one in one of my cases. And then question answering and some other ways. For question answering, a typical example is Google search, because it's not just answering your question based on keywords. You don't have to put, maybe if you remember, let's put 5 years ago, if you were doing some search at Google, you used to use keywords. I don't know, apple pie recipe. Or now you can say, how can I make a lactose-free apple pie? You can put it in a more natural way, and Google will understand that. Google implemented the BERT-based algorithm through the whole world back in November last year. And that's one of the reasons why he was researching, or Google was researching, etc., etc. So let's see the use cases. And the first one, as I promised, it was a similarity assessment. This is a project that we did with Ipsos, is the third largest market research company in the world. They do research in 140 languages, and they use lots and lots of questionnaires, because that's the base of their business. So they came to us with a very specific issue. There was not really issue, but they wanted to improve the way how they were creating those questionnaires. One is that they wanted to have a homogeneous way to create this project. So let's say if a market research in Asia is creating a questionnaire, the same market research in the UK should do in a similar way than in Asia. They don't want to have people asking the same question in a different way, and it has some standardized way through the company. For example, if I wanted to know the age of the person answering the survey, so if I ask you, how old are you? Or I ask you, what year you were born? I'm getting kind of the same information. I'm aiming to the same, but I'm not using the same type of question. They wanted to avoid that. They wanted to make more homogeneous way to do the questionnaire. The second one is, once they have found all the similar questions and decide which one is the best, within each question, find the best wording. What will be the best way to ask this question? And then use the whole knowledge of all the work that they have done in the past to create kind of like a question library. So if a new researcher comes and needs a new project, they don't need to start the whole survey from scratch. They can make use of all the knowledge that they have been using in the past. So in other terms, we created a question library for them. So here is an example of some of the prototypes that we did for them. Here I'm using the query question, what is your primary bank? That was one of the things in the surveys. And then the similarity looks at all the questions that by meaning of a semantic similarity are same to my query question. So the first one is quite similar, very, very similar in words, and is this your primary bank? But it's a yes or no question. But the second one with 0.90, so 90% of similarity with my query question is, and which of these is your main bank or financial institution? Totally different, two different questions. Let's see the wording, that maybe the primary is in the, no, bank is the only word that is in common, but all other words are different. But at the end of the day, it's the same question. So this is how they did it. We created a question library using semantic similarity, and then they scrap out all the similar questions and leave only the ones that they wanted to use. So that was for similarity. Now my second use case on this field is a Nordic, a big company in the tech industry that answers lots and lots of RFPs, requests for proposal. I don't know if everyone is involved with this. Fun job. So they have a lot of RFPs to answer. Each of them can cost a lot of money, and also each of them to be able to respond costs a lot of money because they have a huge team, a bidding office in India that the only thing that they do is to apply those requirements. Time, money, it's a manual process. It is prone to errors, etc., etc. So they wanted to see if they can do something to make it more effective or more efficient. So we say, sure, let's try NLP. So we run a POC with them, and these are the kind of, we also created an interface. This is, of course, demo data. We're not using any of our customers' data, confidentiality, of course. But what we did was, okay, so they have this process, they receive RFPs, they know they need to find answers to these requirements, or how to better say, yes, we comply with this, and this is how we do it. So in other ways is, they have one requirement, the normal work that the bidding office still does, because it hasn't gone to production yet. We are finished the POC and now we're going into the pilot, is that they go and look at the requirement, they start looking and browsing data, data sets, previous RFPs, find the question, put it out into the document, and then go to the next question, and etc., etc. So we did was, okay, let's upload all the requirements, In this case, it was an Excel spreadsheet. It has 60. This one is quite short because they said that sometimes more than 100 questions to RFPs. And then we use similarity request. It's a combination, it's a couple of combination of question answering with similarity, with semantic similarity. So if we look at, for example, one of these, that number 6, they open here the editing tool. Then what it has is it comes ranked by the most similar request what the system has found on previous RFPs. So here is 95%, 83, and then I guess we have a threshold of 76. Everything lower than 76 don't even show it. So what the people now need to do is review the answer that is brought. Does the answer replies to the requirement? And if it's okay, just use it. Use the button or just look at the document. It may be this. Because some of them, the ones that are showing with full compliance, that means that that answer has been used before in another RFP. But if they found the answer, but it hasn't been used in the past, it won't show full compliance. So then the person answering can go to the original document, read, yeah, it is okay, where is it coming from, could we get the compliance, and then there is a place where they make this compliance. It's another button somewhere. So that's the way how they're doing it. If nothing comes here, then they can go to the product descriptions, and it is okay. We couldn't find anything, but then let's find another way to see where we can find that information. And it works pretty much similar. Go highlights in the document, existing documents, where information that it can reply to that question could be found. So the result was very positive. Spoiler alert. We did 3 rounds of tests. We took an RFP, only 10 questions, very, very short for the standards. And we had 3 different groups answering that RFP. First, we asked them to do it without any help of the system. And they took 30 minutes to answer. Then we say, okay, use the system. So the first time using the system, they have 16 minutes in average to use it, maybe getting used to it. By the 3rd time, answer the 3rd RFP, they went down to 10 minutes. Then it's okay, let's do it again twice. Same 3 teams or 3 experts, same 10 questions, same 10 RFP questions, but older questions. And then the results stabilized around 6.5 minutes. Yes.
Sorry, isn't there a risk that the officer doing that becomes something due to the fact that they actually trust the system?
I'm going actually to say that, exactly. So what we saw, and we asked and we interviewed the Vidinofen, is that now the time, they didn't go down this time, the 6 minutes. It's because they were reviewing the answers. They were looking at if the system finds the answer for me, now they are spending the time to review that the answer is correct and accepting it to the system. So it might be a risk, but then it is how you manage this risk. In this case, it was a reduction of 67%. So we are not replacing them totally. We need to know humans. We need to have humans in the loop that it reviews that the answers that are being found by the system really comply with the requirement, and that's the time that they were spending. Other example projects. So now we start with AI. Talk really briefly on image breakthroughs, how you use image analysis or image recognition or computer vision. Went down to NLP, but now I'm zooming out again. Just to, okay, let's go back to the whole AI. And I'm just going to show a couple examples that engagement that we have with customers, and this one is with the imaging in the additive manufacturing. So instead of subtracting material to create a piece of some size or shape, you create it with 3D printing. You use laser, and in this case is melted melt-down powder that you were creating layers and layers to form that piece. The goal is to predict that a build job is going to crash. before it crashes or before an item is created defective, and then it has to be disposed. So according with the experts, if they see the design, they can predict that it's going to crash, but now we're using a system to help them to do that before it happens. So saving both time, money, and material. Second one, it is a TechMet company, a Swedish TechMet company that it is in the business of specific, looking at the skin and seeing if it's carcinoma, melanoma, etc., etc. But they use a device, and within the device they use these electrodes, and this electrode has these pins that it sends some electromagnetic waves through the skin, and they read what it comes back. So they started using the platform a year and a half ago. We helped them at first, and this is just they're just going by themselves. This specific defect detection was, they told us they were doing it without us knowing. So they realized that they have people looking at those electrodes. They have 260 plus pins. They look through a microscope, and if one pin is defective, it's okay. You can still use the whole electrode. But if two or more are defective, they have to dispose that electrode. So they decide, well, let's use image classification. So they take a picture of the final chip or electrode in the manufacturing line. The same system says it's defective or not, and then those people can dedicate to some other tasks instead of looking through the microscope. And the last one is in the construction industry. And the idea is that experienced operators are using heavy machinery to do a task. Once again, I need to keep confidentiality of this customer, but you need to do a task with this heavy machine. And if you're an expert operator, you know exactly when to stop, you know exactly the speed that you can operate that machine, and you need a lot of variables that it goes into having a good finished task, okay? And this is evident with not the junior operators. They don't know, they stop doing the task too soon, so it doesn't really reach the quality that they're expecting, or they run the machine too much, so they passes the optimal level, and then it starts to degrade. So they say, okay, can we see if AI can help? So we are using sound or audio from the machines and vibrations to see if we can find that point. And this is a POC close to the end, and it's really, really showing very amazing results. Preliminary results are very positive. So that's what I wanted to share with you. Happy to talk about any of those cases in the QA. And now I'm going to give the word to Alex from our partner, Neiron.
Thank you, Diana. Hi, my name is Eris. I'm one of 4 Swedish co-founders of Neiron. We are an AI company, or put it an AI consulting company. We started a few years ago, and we set up an office here, and we set up an office in Georgia. Why Georgia? Well, because it has there's a lack of talent in Stockholm, and it's really expensive. They want to find. So we found that everything worked very well in Georgia, and we have some good friends over there. And it's an amazing country to go from time to time. So recommend you to go there. Skiing not so bad either. We got some support by Swedfund to actually partner up us for to get the company going. And now we are between 10 and 12 people locally in Georgia. And we've been partners, and we have become partners with Euvic and Peltarion. Our services is mostly consulting, as I said, and especially what our customers like is the AI readiness assessment. I will come back to that later. But other things we do is predictive analytics, image analytics, NLP, and of course the data mining and big data parts. That's a big, huge part of the AI. I'm going to show you two example cases in two totally different industries. The first one is a chips potato manufacturing company in Georgia, and they are the largest chip maker in the whole region. They are manually going through different parts of the chips every day. They have 8 people working full time with it. And we thought, why do we have people doing this when we can use AI? So we set up a system on their conveyor belt computer, which analyzes everything. Some AI specific hardware. Nowadays you can buy some really compact computers that just made for AI. Set up cameras. And there's a lot more complex things on that. And then we started running this, we trained it, and at the end we came up with some really good results. So this is an idea how to show how an AI can actually recognize different objects, even though they are very similar, they can still understand it. And why I'm showing this example to you is that if you have anything that uses images, then you can think about that. You can use this. I mean, it's used a lot nowadays. For example, in traffic, they're registering your license plates and so on, which is a really simple one because it's only letters, but this is like more complicated. But from this, it can actually recognize which one are faulty. The green ones are good, and the red ones are faulty. And for these, we use different kind of techniques. It doesn't have really a meaning for you, I guess, unless there were a few here that have been playing around with these things. And now the second part of moving from image-based AI to more data and time-based AI, put it that way. We have created for a customer, we have created an option trading platform which analyzes using NLP, for example, and BERT, as Liliana explained it. It doesn't get so confused as the traditional models usually use, because you have trading companies have been using NLP for a long time, but the results that you get out was not as good as they are nowadays. So by processing a huge amounts of data, we went through Facebook, Twitter feeds, news, press releases, anything you can find out there, and we gathered a database with more than 1 million articles and posts. And from there we started to see what we could get. We had different kinds of algorithms, and we tweaked them. And it's options, but we of course are using the stocks as underlying to predict parts of the option trading. The results were pretty good. Using NLP, we got some results, but combining it with deep learning, which means NLP was just for the textual parts that we took in order to do 1 million posts and articles. But then we use deep learning as well for more unstructured data. And with that, we could get it up 8% more. But this 8% is really important in options, because in options you have more or less a hit rate, because it's a finite instrument, so it has an end date, and if you get 8% better results at the end, it will actually give you a lot better results. We've been testing this back and forth for a few years, and we are more or less live. Can't tell you much more than that. But the worst results we're getting now is 20% return per year, and the best results is 80% per year. Of course, if you use enough data, you could probably get like 1000% return, because the algorithm could find the exact ones. But we are working a lot with the risk management. So the most important part is not to lose money, but to gain money. So we're aiming more for the 20% per year and hoping to come up for the 80%. And this is many years of research behind it. And we will see how it goes from there. But it's extra interesting now with the coronavirus and the oil price changes. Gives in a better edge with options at the moment. So, how to get started? Those things were just examples of what you could do with AI. For your own organization, I guess you have like different kinds of systems. You have an ERP system, business system, you have bookkeeping, you have transactions, everything. All that data you can actually use to see and find if you can find bottlenecks. You can actually do predictions, especially if you're doing manufacturing. You're putting in an order. You can see how long you will get your money back based on other data before. And you can also use data from other countries if you're a global company to see how fast it will come back. And you can add the weather. The weather, for example, will make an impact on if you're selling winter clothes, for example. But that you could have in your model earlier, because then you could know, then you would know that how to go forward with that. AI will solve everything you have, but by digging into data you have in your own company, you can usually find quite a lot of interesting things that you can improve. And the biggest problem that we've seen with those companies we're working, because we're working a lot with non-AI or more like industry companies, we've seen that they don't know where to start. And the best start is to do an AI assessment, which means that we come on site, we talk with different units at the company, we sit down, we look at any data you have, we look at the quality of the data, and then we give you a report based on on a scale 1 to 10, give you an improvement on. We give you ideas on what areas you could improve and where you could maybe start doing smaller projects within the company, where you can find the bottlenecks that we can improve.
And then I just want to complement the advice on how to get started. And this one are actually from our head of AI research at Peltarion, Anders Architect, who is former AI of research at Spotify. We like to brag about that. Anyway, so he says one of his advices are to come together and learn the fundamentals of AI. And as I mentioned earlier, AI is going to change the way how everyone is living, working, and interacting with each other. And it is important that we take that step to know what the AI technology means, how it can be used, how it's going to be affected, and how can I do as a citizen, as a leader of an organization, or as a data scientist and ML engineer that creating the system, how it's going to affect society as a whole. So very important to come together and learn the fundamentals of AI. Second, pick the right problems. AI cannot solve everything. First, you need data. So if you don't have data, or your process that you are going to make more effective is not really run by data, you cannot use AI. So pick the right problems. Start with a big picture of what you want to accomplish, but then slice that problem in a small steps. Start small and then scale. And then, as Aris mentioned, AI assessment is a great tool to start with. Third is fail fast. Don't be afraid to take risks. This technology is going in enormous speed. If you doubt to take risks, you're gonna be left behind. Take risks, fail fast, learn from those mistakes, and then that is gonna save you time in the future when you find the right use case, because you have already learned how to process the data, what you need to look, what you failed in the past, so you would not fail in the future with your 10% of more promises use cases that surely you might find in your organization. And the last is pick the right tools and platforms. Don't reinvent the wheel. There is a lot of frameworks out there. There is a lot of good platforms out there that can help you to speed up the process of applying AI. And I might be a little bit biased, but I highly recommend take a look to our platform, the Peltarion platform. We have a community edition. Everyone can sign up, platform.peltarion.com. Sign up, look at our resource page. We have lots of tutorials with classifying car accidents, for example, with the data set, with instructions, and with what kind of algorithms you can use in the platform. Very step by step to use. We offer 50 GPUs hours, so that's gonna give you a lot. You can even bring your own data and test, so you don't have to sign for anything. That's the first one. Back onto the learning the fundamentals of AI. So people in the room, you're gonna get this book at the end. This is something that we had brought as a good information of what the leaders need to think of, and also how you can go it through the organization. So feel free to take one. If we have over, take two, send it to your colleagues. And for the people online, we have the access to the book in a digital format into that link. And then there is also a free online course. Did you know about this one, Elements of AI? Few? Okay, few there, good. So this is also a good resource. It was an initiative that started for the University of Helsinki and Reactor a couple years ago, if I'm not wrong, maybe 2-3 years ago. Don't quote me on that. But they started with, as a goal to educate 1% of the Finland's population on AI. You got a really good response from the people in Finland. Even their minister challenged our minister of something, don't call me that either, that who will train more people in Sweden or Finland. I don't know who won. I hope we did, but since I haven't heard anything, maybe not. But the idea is that now they have changed the goal that not only 1% of population in Finland that's going to get trained on AI, is 1% of the world's population. And with Innovation Sweden, AI Innovation Sweden, Vinnova, AI Competence, Linköping University, Peltarion is a partner on this initiative, and it has helped to translate the whole site to Swedish. So go and also look at the nice resources that they have there. I guess with that, I'm going to invite Aries and maybe take some questions if you have.
Shy. Or you can talk afterwards too if you have some specific questions.
Maybe.
Yeah.
Yes.
Your platform does offer all of those 8 or 10 methods to use differently. So you presented a slide with different methods, semantic.
Yes, very good question. I'm going to repeat the question for the ones in the back. They didn't hear. So the question is, does the Peltarion platform offers all the different NLP tasks that I present already? Not all of them. We are working on adding some functionality, but text similarity, question answering, embeddings, they are already in the platform. We introduced BERT in the platform back in October last year, or September, October last year. Not with the whole functionality, but we added functionality all the time. But we have all other models like fast tests that Arias mentioned, that is in the platform. So we have other algorithms there to test. So it is good. You can run a tutorial and see and compare the results by using a traditional model and a BERT model and see which one performs better. Yes.
So from your perspective, you see a lot of AI projects and so on. Two questions. What industry do you see the most potential in? So from your perspective, where would you really go for AI project if you were in that industry? And the second question is, what industry has come the farthest? So where would I, as a competitor, be the most scared of being behind?
Very good question. So to answer that, which industry I see that it has been kind of more beneficial, it is hard to say the industry or the vertical, because everything comes down to what is the task that you want to accomplish. So even if you are a public sector, or you are in the finance sector, or you are in manufacturing, construction, or technology, if you need to identify something in an email, or you are surveillant, I don't know, if you need to identify something from an image or a video, it doesn't matter which sector you are, you can use these algorithms to speed it up and make that process more effective. Same thing with text. Text, it is in every company. So it doesn't really need to be that the legal companies, organizations are going to make more use of NLP, because it could be the same for finance or public sector or technology. It's specifically the case. The ones that are going to succeed, of course, are the ones that start testing, start seeing what they can be done with AI, and that perhaps would be the ones that are farther away. Medical diagnosis has been really predominant in the image analysis field. Maybe because it's on resources, maybe because it could be different reasons, but that's a clear example that having systems that help radiologists to detect or to interpret the images can make a big difference. So it depends a lot on what is the task.
You could say that any business where you have a person looking at something and actually taking a logical decision on it. You look at something and take a decision, you can leave that to the computer, to the AI to do that for you.
As long as you have good enough data.
As long as you have good enough data, yes. But you will get a lot of data. So you can think about the bookkeeping industry right now. Actually trying. There are a few companies doing that. They're like looking at all your receipts and all that, putting it straight into the system and pay you out where you have. Also I'm a bit biased on the financial industry, but also there you have like well-paid guys who are and girls watching screens, reading stuff, and taking decisions which are usually not logical. They should be logical, but sometimes they have a bit too many feelings in the decisions. And if you use it in AI, you can remove the feelings and you can actually do logical decisions better.
So what is it that you can't leave to machines?
Cannot leave to the machines.
Yeah, I would say the soft parts. In healthcare, I would say, of course, the image recognition. It's a tool for the doctors and nurses. It will help them. It won't make them. They won't lose their job. It will just help them. But you still need professions where you actually talk to a person sometimes. And of course, if you're an artist, you can let the computer create music and paintings, but it's still not the artist. It's still an AI. So it still kind of does what it's programmed or learned earlier. The human is more. It's a bit more weird. Put it that way. Can come up with if you go to an art museum, you're just like, how did this person come up with this? This looks something I've never seen before, And yeah, so there are things that humans cannot really replace. But we'll see.
Yeah, something else is like Ali said, like in emotions, like when you choose the affection, that kind of is only left to the humans, the showing the caring for someone that is sick or caring for someone is sad. But also, now I lost what I was gonna say. No leave to the machines to do. To use AI effectively, you need to, well, once use data, but even if you don't have data, you're going to collect the data. You can use sample data just to prove a hypothesis, and then dedicate the next year or so to collect your data. But what you cannot leave to machines to do AI is when you have to make decisions that are not repetitive. So let's say if you need to make a decision once per month or once per year, AI wouldn't give you that. It's better to give it to a business analyst. They can put everything in place and make that decision for you. But if it's something repetitive that it really needs to make a decision in the moment that it's happening, then that is a good case. So e-commerce, you're selling products online, you have people that can shop, put items in a shopping cart, and if you can predict if this person is going to do a checkout or just abandon the page, there is when you can have a system that says, okay, make an offer to that person so he doesn't abandon the cart. But if you are looking at places to open a new office, perhaps that is not going to be good for anyone. So that's the repetitive decisions that is a good thing. Doctors with the coronavirus, 20 seconds instead of hours, they need to have this diagnosis fast. Screening lots of text. Examples with the RFP, they need to look at a lot of data. Just skip that, leave it to the system, and leave the humans to analyze the answers. Yes, this is good, maybe change that.